Hello everyone, welcome to my channel. Today we will discuss Leetcode question number 162, which is find the peak element. So let's read the question. A peak element is an element that is strictly greater than its neighbor. Given a zero index integer array nums, find a peak element and return its index. Means we have to find the peak element and we have to return its index. If the array contains multiple peak elements, return the index of any peak. So we have to return any one. You may imagine that nums minus 1 and nums n as minus infinity. In other words, an element is always considered to be strictly greater than neighbor that is outside the array. So it is saying that key if this is a given array, then whatever element is at the beginning and at the ending, so element before that is considered to be lesser than this. Means whatever value here it will be, the element before that will have lower value than that. And for the end index also the same. The element after that, after the last index, would be considered lesser than this element. It is saying the same, that it is considered minus infinity. In other word, an element is always considered to be strictly greater than a neighbor that is outside the array. Yes, so after that, yeah, it is saying that you must write an algorithm that runs in of log n times. So let's see the example discuss. Yes, so it is given 1, 2, 3, 1. So 3 is the peak element. The function should return index 2. Okay, so you can see that 3 is the element. Whatever element to the left of 3 and to the right of 3 is lesser than 3. So 3 is the peak element. And for the next example case, it is 5. So it is index 5, which is this element 6. So 6 is the element. The element left of 6 and the element right of 6 is lesser than 6. So 6 is the peak element. Another peak element is also there, which is this 2, because the element left of 2 and right of 2 is 1, 1, which is lesser than 2. So 2 will be also a peak element, but we need to return any one, either this index or this index. So let's discuss the approach. So one of the brute force approaches that we can simply iterate this array, and for any element at an index, we can check its right and left element. If both of them are lesser than the current element, then that is the peak element. So the time complexity for that will be O of n. But the question is saying that you need to do in log n times. So let's discuss how we can do it in log n times. Okay. So you are given this array. So it is like something, if we will create a graph, it will be like this. This is 1 and this is 2. Then again 1, then again 3. Then again it is 5. And again 6. And again it is 4. So we can see that it is forming two peaks. One is here and another is here. Now, so how we can do it in log n times? Okay, if time complexity is saying that it should be log n, then only one thing comes to the mind. What is that? That is binary search. So we need to use binary search. Binary search is the only proof that we can use to do it in a log n times. So how we can use binary search here? So what we will do, uh, we will apply binary search here. We will take left pointer at this and right pointer at this. Okay. So why we are putting left pointer here only and right pointer here? I will explain it at the end. Okay. So, and uh, we will find the mid. So let me mark the index also. That is 1, it is 2, it is 3, it is 4, it is 5, and it is 6. So our right pointer is at 5 and left pointer is at 1. So 5 plus 1 by 2 is 6 by 2, which is 3. So our mid will be at 3, which is here. Okay. Now we will check left and right of this mid element. If both of them are lesser than this 3, then the element that I'm standing or the element at the mid is a peak element. But we can see that right element is 5, which is greater. Now we have to, so this is not a peak element. Now we have to decide whether we need to go to left or we need to go to right. Okay. How we will decide? So we can decide checking the mid element. If element on the left uh, element on the left is smaller and element on the right is bigger, element on the right is bigger, so whichever side is having the bigger element, our peak will be on that side. Our peak will be on that side, uh, because if graph is like this and I am here and I have to go to peak, then it is obvious that the element next to it might be greater than. So if it is greater, then the peak is this side. So we will move to the uh, to the direction where the element is larger, because our peak element will be on that side. So what we will do, we will move our left pointer uh, left pointer to mid plus 1, which is 5, and our right pointer will be there only. Now left index is 4 and right index is 5. So 4 plus 5 is 9 by 2, which will be 4.5, which will be round up integer to 4. So yeah, 4. So our mid will be here on the left only. Now we will check whether the left and right element, whether this is a peak element. So for that we need to check the left and right element, whether both of them are smaller than this. Then we can simply return this mid, but it is not. Now we will check which direction we have to move. So we can see that uh, we are having element larger than 5 on the right side, which is 6. So we need to move that side because our peak element will be there only. So again, what we will do, we will move our uh, left pointer to mid plus 1. So mid is here. So our left pointer will be mid plus 1, which will be here. Now at this point, our left and right are at the same point. Now this index is 5. So again, we will find the mid. 5 plus 5 by 2. So 10 by 2 will give 5. So that will be the mid only. Now, now we will check whether this is the peak element. So we can see that it is the peak element because element to its left and element to its right are smaller. So we will return this index, which is 5. Okay, so we got our answer. Now, why I have taken my left element at one index and my right element at uh, the second last element. So let's see one example. Suppose your given array is 1 and 2. So graph is something like this. Okay. Now this is zero index and this is one index. If I will find my mid, what I will get? I will get 0 plus 1 by 2. 0 plus 1 by 2, which will be 1 by 2, which will result to 0. So our mid will be here. Now, standing at this index, I have to check its right and left element. But there is no left element. So in this case, we might get index out of bound error. So that's why that's why uh, I'm starting my left from here and right from here. Okay, so and we'll handle these two index separately. How we will handle? Suppose we searched in this region for our peak element and we didn't get. Then obviously our peak element will be this one or this one. Okay, so if this or this is our peak element, then we can simply return the max of these two. Means whichever will be max will be our peak element. Let's see in this example. So if I will, if there are only two elements, then I will have my L as 1 and R as length minus 1, which is 2 minus 1, and sorry, length minus 2 it will, because I have to start from here. So it is length minus 1 and it is length minus 2. So R will be 0. So it will not go into my loop, and at the end, uh, it will not go inside the loop and it will not get any result. So at the end, I will check which is the max of these two elements. So whichever will be max, that will be our answer. So let's see the code. So I have added a condition that if the containing only one element, then simply return 0, because one element means it is at the 0 index, so that will be the answer only. And after that, I have taken L and R, L as 1 and R as size minus 2. And I am running a while loop till L is lesser than or equal to R. And after that, I'm finding mid, and I'm checking whether our mid element is the peak element. I'm checking that if element to the left of mid is lesser and element to the right of mm, right of mid is greater. Sorry, element to the right is also smaller. If both are smaller, then that is our peak element. So in that case, I'm returning the mid, which is the index. If not, then I am checking whether the element on the left is lesser. If it is lesser, then our peak lies on the right. So I'm moving my left to mid plus 1. Else I'm uh, moving my mid to uh, sorry, moving my right to mid minus 1. And if I am not getting result in this range, then it is obvious that our result may be the 0th index or the last index. So here I will add a check whichever elements. Suppose nums of 0 is greater, then I'm returning the 0th index. Else I'm returning the length minus 1 index. So let's run this code. Yeah, it's passing all the given test cases. So let's submit it. Yeah, it's passing all the given test cases. So time complexity for this is of log n, as we are using binary search. So that's it. Thank you for watching. Do like, share, and subscribe.